Our planet's climate is shaped by powerful oceanic forces, none more influential than the El Niño Southern Oscillation, or ENSO. Deep in the tropical Pacific, ENSO pulses between two phases: El Niño, the warm phase, and La Niña, the cool phase. La Niña, meaning the little girl in Spanish, occurs when surface waters in the central and eastern Pacific become unusually cold. This isn't a minor event, it's a vast cooling that can shift weather patterns worldwide. Strong trade winds push warm water westward, allowing cold, nutrient-rich water to rise along South America's coast, a process called upwelling. During La Niña, these winds intensify, expanding the pool of cold water and triggering a global chain reaction. The result: weather patterns shift dramatically, with some regions facing drought and others, floods. La Niña alters the jet streams, those high-altitude rivers of air that steer storms, nudging them off their usual paths. This can mean drier winters in California, wetter seasons in the Pacific Northwest, and even changes to hurricane activity in the Atlantic. For centuries, people have felt La Niña's effects without understanding the cause. Today, science allows us to track these oceanic shifts and anticipate their impacts. This knowledge is crucial. It helps us prepare for the extremes La Niña can bring. La Niña isn't a disaster, it's a natural rhythm of our living planet. But its reach is vast, reminding us that what happens in one part of the world can ripple across the globe. Understanding La Niña gives us a chance to adapt and build resilience. The story of La Niña is a story of connection, one that links oceans, weather, and all of us. The West Coast's climate is at the mercy of the Pacific Ocean, and La Niña is its wild card. When La Niña arrives, the region can swing between two extremes: deepening drought or overwhelming deluge. Typically, La Niña pushes the Pacific jet stream north, diverting storms away from California and Oregon, leaving them dry. The result? Water shortages, thin mountain snowpack, and increased wildfire risk. But La Niña can also bring the opposite: catastrophic flooding. Sometimes the jet stream kinks, creating atmospheric rivers, narrow corridors of moisture that unleash torrents of rain and snow. These rivers in the sky can overwhelm rivers, trigger landslides, and flood communities in days. This dual threat makes planning difficult. Residents must be ready for both drought and flood. Infrastructure built for one extreme can be tested by the other. La Niña's unpredictability demands vigilance and flexibility. The question isn't if La Niña will have an impact, but which face it will show this winter. For the West Coast, every La Niña is a roll of the dice. Preparation is the only certainty. La Niña's cooling of the Pacific sets off a chain reaction in the atmosphere. Cold water chills the air above, creating a high-pressure zone, a kind of invisible mountain that blocks storms. This blocking high deflects the storm track north, leaving California in the southwest dry. The result: below-average rain and snow, shrinking reservoirs, and stressed water supplies. But the atmosphere is never static. Sometimes the high-pressure ridge shifts or weakens, opening a channel for moisture from the tropics. That's when atmospheric rivers surge in, carrying the water equivalent of the Mississippi River. When these plumes hit the coast, they unleash torrential rain and heavy mountain snow. A single atmospheric river can deliver a month's precipitation in days. If several arrive in quick succession, the land can't absorb the water. Floods and mudslides follow. La Niña's legacy depends on subtle shifts in the atmosphere: a dry winter, a flood, or sometimes both in the same season. The difference between drought and deluge can hinge on a small change in the jet stream. This is why La Niña's impacts are so hard to predict and so dramatic when they arrive. The West Coast must always be ready for either extreme. La Niña keeps everyone guessing. History shows La Niña's power to swing between extremes. The winter of 1976 to 77 brought a severe La Niña drought. California's reservoirs dwindled, water was rationed, and crops suffered. In contrast, 1998-99 saw La Niña deliver relentless storms to the Pacific Northwest, causing major floods. More recently, the 2020-2023 La Niña locked the Southwest in a punishing drought, dropping Lake Mead and Lake Powell to record lows. Yet, in 2022-23, a series of atmospheric rivers hit California, flipping the script from drought to flood in weeks. These events reveal La Niña's unpredictability. One region's drought can be another's deluge. Sometimes, the pattern persists for years, compounding its effects. Other times, a sudden shift brings dramatic reversal. The lesson: La Niña's impacts are never uniform and history is full of surprises. The only constant is change. Atmospheric rivers are both lifeline and threat for the West Coast. These narrow bands of moisture deliver much of the region's winter rain and snow, replenishing reservoirs and building snowpack. Without them, cities and farms would struggle through the dry season. But when atmospheric rivers are too strong or too frequent, they become destructive. Floods, mudslides, and infrastructure damage can follow in their wake. La Niña can steer these rivers north or send them barreling into California. A slight shift in the jet stream can mean the difference between a welcome storm and a disaster. Scientists now rate atmospheric rivers to help communities prepare. Like hurricanes, they range from beneficial to hazardous. The West Coast depends on these rivers in the sky but must always respect their power. In a La Niña winter, the line between blessing and catastrophe is razor thin. Forecasting La Niña's impact is a meteorological puzzle. Scientists can spot La Niña by tracking ocean temperatures, but predicting local weather months ahead is far harder. Other atmospheric patterns, like the Madden-Julian oscillation, can override or amplify La Niña's effects. The atmosphere's chaotic nature means small changes can have big consequences. A wobble in the jet stream or a patch of warm water can shift the entire season's outcome. Climate models offer probabilities, not certainties. A drier-than-average forecast still leaves room for floods. That's why a winter can start with drought warnings and end with record rain. Our tools are improving, but nature still holds surprises. The best approach is to expect the unexpected. Preparation, not prediction, is our strongest defense. On the West Coast, preparing for both drought and flood is essential. Households can conserve water by fixing leaks, using drought-tolerant landscaping, and installing efficient fixtures. At the same time, flood readiness is crucial. Know your risk, have an emergency kit, and plan evacuation routes. Securing important documents and considering flood insurance are smart moves, even outside high-risk zones. Communities must diversify water sources, recycling, stormwater capture, and managed aquifer recharge. Turn excess water into a future resource. Investing in infrastructure and public awareness campaigns builds resilience. Everyone has a role: government, community groups, and individuals. Clearing storm drains, restoring wetlands, and maintaining levees all help reduce risk. The goal is a culture of preparedness, where drought and flood are met with calm, coordinated action. By working together, we can weather whatever La Niña brings. Resilience is a shared responsibility. West Coast ecosystems have evolved to survive La Niña's extremes. Native plants grow deep roots or waxy leaves to endure drought. Some go dormant until rain returns. Drought intensifies competition for water, and wildfires become more frequent. But fire also renews the land. When rains arrive, the transformation is dramatic. Wildflowers bloom, animal populations rebound, and rivers swell. Seeds dormant for years suddenly burst to life, taking advantage of the brief abundance. Temporary wetlands form, supporting birds and amphibians. These cycles of scarcity and surplus have shaped resilient, adaptable ecosystems. Nature's lesson is clear. Survival depends on flexibility, not stability. As we build our cities, we can learn from this, designing systems that adapt to both drought and flood. Mimicking nature's resilience helps us coexist with La Niña's unpredictable rhythms. The environment thrives not by resisting change, but by embracing it. So can we. As another La Niña winter approaches, uncertainty is the only guarantee. Climate change may be amplifying these natural cycles, making extremes more common. But uncertainty isn't cause for fear, it's a call to action. We must build communities that can absorb both drought and flood, valuing water and preparing for volatility. La Niña reminds us of our planet's interconnectedness and power. Science gives us foresight, but not control. Our best tool is awareness of risks, vulnerabilities, and the steps we can take. By heeding forecasts and preparing for both possibilities, we can face La Niña's challenges with confidence. The ocean will continue its dance and the atmosphere will respond in kind. Our task is to watch, learn, and be ready, protecting our only home with wisdom and care. The future belongs to those who adapt.